Astro, and this is the Astrophotography channel. Today's topic will be on light pollution. So without further ado, let's get right into it. So, what is light pollution? I gave it a quick Google, and according to Wikipedia, light pollution is the presence of anthropogenic and artificial light in the night environment. Now, this is a bit of a strange statement to state, because I would have said anthropogenic and artificial would be the same unless you're applying something not human created light, artificial light. But hey, so I don't know who, it might have been written by a conspiracy theorist, I don't know. Anyway, so then it goes on to say, it is exacerbated by excessive, misdirected or obtrusive use of light. To even carefully use light fundamentally alters natural environments, or conditions should I say. So yeah, that's that. But according to the International Association for Dark Skies, their interpretation of it is the inappropriate or excessive use of artificial light, known as light pollution, can have serious environmental consequences to humans, wildlife and our climate. And they stipulate there's 4 different components to this, and so let's get on to the 4 components. And these are glare, which according to them is excessive brightness that causes visual discomfort. So to me this would mean, like, for example, in a car at night, and the car drives past you with its lights on, little beams. You get that dazzled effect. You can't really see. Your eyes just washed out. You can't barely see anything else. So that's what I take it to mean by glare. So that could be something very bright, like for example a floodlight. They can be really bright if you're looking in that direction. Anyway, on to the next one, sky glow. This is what most people think of when they're talking about light pollution in terms of astronomy and astrophotography. So this is the brightening of the night sky over inhabited areas. So this is effectively due to all that light that is generated by human activity. So all the street lights, building lights, any kind of light, artificial light you can think of that basically goes outside, basically contributes to this, and it effectively causes what's known as a light bubble, or sorry, light dome, should I say. Just 1 minute. It's just a bit stiffer. So basically, this is caused by particles in the atmosphere. So this can be dust, aerosols, anything that's basically suspended in the air can basically cause this light to be reflected back, and this causes the glow effect. So, which we'll get on to later on. So anyway, on to light trespass. So this is basically. So they state that light falling where it is not intended or needed. So this is, for example, street light shining through a bedroom window at night. Again, a floodlight shining into your neighbour's garden. Anywhere, anything that basically is unwanted light, basically, would be considered to be that you don't control, would be considered to be light trespass. So yeah, that's pretty simple on that one. And then clutter is very confusing, excessive groupings of light sources. I was trying to think of an example of this, really, apart from maybe a building that's got a lot of lights all over it. The only real thing I could come up with is something very temporary, like fireworks, big flashes, basically, goes together. So it's but really, I think the first 3 are the more important ones when it comes to astrophotography anyway. So let's move on. So how do we measure it? So there's a gentleman back in 2001 who developed what is now known as the Autoscale. This was developed by John E. Bortle. His aim was to help amateur astronomers and astronomers alike, basically the primary amateur astronomers, to compare, how dark sites were, that kind of thing. So this was developed back in 2001 and published in the Sky and Telescope magazine. Anyone interested, I will actually put links into at the bottom for anyone who is interested in that. Anyway, on to the Autoscale itself. So the Autoscale there are a total of 9 different classes, so ranging from 1 to 9, 9 being the brightest sky. So let's go on with this. Let's go through this. So 9 is known as inner city sky. So if you look at my chart here, I've shown a very sort of white sort of colouring, and basically the maximum magnitude of stars you're likely to see here will be magnitude 4. So basically, the description of the sky would be: the sky is pretty lit. Only objects to observe are the moon or the planets, and a few of the brightest star clusters. So basically, magnitude 4 stars. Anyway, so you wouldn't be able to see that much in the way of faint stars. They'll be totally washed out. But the planets, the moon, you should be fine for those generally, providing you've got there's no additional light sources around you, of course, but it might exacerbate it. But anyway, on to class 8. This is city sky, and I made this sort of light grey to reflect the sky colour. So you get a maximum magnitude of 4.1 to 4.5. So stars should be able to see, realistically expect to see. So the sky is sort of light grey. Well, can easily read by the light. So stars forming familiar constellations may appear to be weak or invisible. So it may be hard to actually navigate just by searching for the stars with your eyes. On to class 7. Class 7 is where I am, though according to the Clear Outside app, I'm Portal 8, but I disagree with that, considering I can see a lot more than you'd expect to see in Portal 8. So this is suburban-urban transition, and the max magnitude of stars expected to see will be 4.6 to 5. So entire sky light grey, as I predicted. Strong light sources are evident in all directions. Clouds are brightly lit. So when they say brightly lit, what they really mean is if you look at the sky, you can actually see the lower clouds, because they're reflecting back the actual light. So over a city, you can actually look quite spectacular at times. Some of the clouds where they reflect the light. But obviously, for astronomy and astrophotography purposes, this is not good. Okay, so on to class 6. I have categorised this with a slightly dark grey. This is bright suburban sky. Max magnitude expected to see stars would be 5.1 to 5.5. The sky within 35 degrees of the horizon allow greyish. The sky within 35 degrees of the horizon glow greyish white. Clouds anywhere in the sky appear fairly bright. So basically, again, you the cloud's going to reflect light, but less light than say Bolton 7, because there is going to be less actual light. So, but there'll still be some. And that's so, but it will still be distinct. Okay, on to. So then we go on to class 5, suburban sky, and I've categorised this with sort of mid grey. This is a maximum magnitude of 5.6 to 6. Light pollution is visible in most, if not all, directions. Clouds are noticeably brighter than the night sky, so it's still reflecting enough light that they're going to be obvious to naked eye. And then on to class 4. This is rural suburban transition, and I've categorised this as a darkish grey. Maximum magnitude of 6.1 to 6.5. Light dome is visible in several directions. Clouds are illuminated in the direction of the light sources, and strands are clearly visible. But directly overhead, you wouldn't be able to see the clouds, kind of thing. So it'd be dark overhead, just not to the horizon where the actual direction of cities or towns, kind of thing, where the light pollution is emanating from. Then we're on to class 3, which is rural sky, which is a darker grey, magnitude of 6.6 to 7. Some light pollution evident on the horizon. Clouds are illuminated near the horizon. Dark overhead. Surroundings are vaguely visible, so you can make out a little bit, like a tree, that kind of thing. But the further you go, you will see compared to class 4, where you can actually see from quite a distance. Okay, so on to class 2, which is a typical dark sky site, which is a magnitude of 7.1 to 7.5. So this would be the sort of areas around me that I can go to that are known for dark skies. That'd be probably either a 3 or a 2. So the air glow may be weakly visible in the horizon. Clouds are only visible as dark holes against the sky. Surroundings are barely visible. So quite dark. So then on to class 1, which is the best we can hope for, really. It's an excellent dark sky site, which has a magnitude of 7.6 to 8. Air glow readily visible. Many constellations, particularly fainter ones, are barely recognisable on the larger number of stars. So basically you can see more, and you'd be able to see, like a class 2 and a class 1, you should be able to make out the Milky Way, the Milky Way band. Obviously, if that's up at that time, you're imaging or viewing. So, but you'll be able to see a lot more. So really all there is to the Autoscale. It's just basically a method of trying to determine before you go there what you can expect to see. So I think it's quite handy to know. And that's the end of this. Part 1 of this video. It's going to be in 2 parts. The next part will be airing in a few days. Will be what can we do to combat it. So basically, what options are there to deal with light pollution. So yeah, so that'll be coming in part 2. So I look forward to that and hope to see you all there. If you like this video, please click subscribe and click the like button and click the notification bell to be notified when new videos come out. And until then, I wish you all clear skies.